Welcome to all. Today we are going to see Unit 5 in Laplace transform. First, a definition of Laplace transform. Laplace transform, let f of t be a function of t denoted for all t is greater than or equal to 0. Then the Laplace transform of f of t denoted by L of f of t is defined by L of f of t equal to integral 0 to infinity e power minus st f of t dt, provided that the integral exists. S is a parameter which may be real or complex. Clearly, L of f of t is a function of s and is briefly written as f of s. That is, L of f of t equal to f of s. In easily, Laplace transform is a transformation. A function t is transformed into s. Now we are going to see inverse Laplace transform definition. If the Laplace transform of a function f of t is f of s, that is L of f of t equal to capital F of s, then f of t is called an inverse Laplace transform of capital F of s. And we write symbolically L of f of t equal to L inverse of f of s, where L inverse is called the inverse Laplace transform operator. Easily, a function t is transformed into s is Laplace transform, but a function in s is transformed into t is called inverse Laplace transform. Now we are going to see the solution of differential equation by Laplace transform technique. There are so many methods to solve a linear differential equation. If the initial conditions are known, then Laplace transform technique is easier to solve the differential equation. The Laplace transform the differential equation into an algebraic equation. Now these two are the formula. L of y dash of t equal to s into L of y of t minus y of 0, and the other L of y double dash of t equal to s squared L of y of t minus s into y of 0 minus y dash of 0. These two formulas are applied in solving ordinary differential equation. Now the formula of the inverse Laplace transform. Where you are seeing the left side is Laplace transform formula, which is in the right side is inverse Laplace transform. For example, f of t in Laplace transform is going to be capital F of s. As well, capital F of s in inverse, then it's going to be f of t. The next second one, Laplace of L of 1 can be written as 1 by s in Laplace transform. As well, Laplace inverse for 1 by s can be written as 1. Now the third one, L of t equal to 1 by s squared. Then L inverse of 1 by s squared equal to t. As well, all the formulas. This also the formula which is in the left side is Laplace transform and which is in the right side is Laplace inverse transform. And Laplace of sin hat can be written as a by s squared minus a squared. As well, inverse of 1 by s squared minus a squared is going to be sin hat by a. As well, cos at also. Now we are going to solve the examples. For a question, ordinary differential equation is solved by using the Laplace transform. Okay, the first example, using Laplace transform, solve the differential equation y double dash minus 3y dash minus 4y equal to 2 e power minus t, with y of 0 equal to 1, as well y dash of 0 also 1. Now the solution. First we are going to write the given equation with condition. After that we have to take Laplace transform on both sides. Then we get L of y double dash of t minus 3 into L of y dash of t minus 4 into L of y of t equal to 2 into L of e power minus at. In the past, we saw the formula of the differential equation. L of y dash of t can be written as s into L of y of t minus y of 0. As well, L of y dash of y double dash of t can be written as s squared L of y of t minus s into y of 0 minus y dash of 0. These two formula is used here. Okay, so L of y dash y double dash of t can be written as s squared L of y of t minus s into y of 0 minus y dash of 0. As well, y dash of t can be written as s into L of y of t minus y of 0. Then the remaining is given equal to 2 into L of e power minus t is written 2 into 1 by s plus a, that is s plus 1. Okay, now they gave a condition in the question. What is that? Y of 0 equal to 1 and y dash of 0 also 1. Now we have to put these condition in the equation. See, s squared L of y of t minus s into y of 0. Y of 0 has a value is 1. Then y dash of 0 is also having a value 1. So we have to using these two values. Then we get s squared L of y of t minus s into minus 1 minus 3 into s into L of y of t plus 3 minus 4 L into y of t equal to 2 by s plus 1. Now see the last one, which is in your left side is all in Laplace y of t, which is in the right side is all in s. Now see, now we are going to put L of y of t as y of dash, that is y dash. See, L of y of t is going to written as a y dash, s squared y bar minus 3s y bar minus 4y bar equal to 2 by s plus 1 plus s minus 2. Then we take the LCM in the right side. Then it gives 2 plus s into s plus 1 minus 2 into s plus 1 divided s plus 1. Okay, now your left side take the common term y bar. Then we get s squared minus 3y minus 4. Now in your right side having 2 plus s squared plus s minus 2s minus 2 by s plus 1. Then which is in your left side is can be written by the divide of the right side. So y bar equal to s squared minus s by s plus 1 the whole squared into s minus 4. That is, see the 2 plus s squared plus s minus 2s minus 2. Then s squared is only one term, but s is two term. Minus 2s plus 1 is minus s. Then 2 minus 2 is 0. Now y bar equal to s squared minus s by s plus 1. Then s plus 1 and s minus 4 is going to the right side. Okay, so finally we get y bar equal to s squared minus s. Consider taking the partial fraction. See, the denominator having the power 3. So we need to take a constant 3, that is a, b, c. S squared minus s by s plus 1 the whole squared into s minus 4 equal to a by s plus 1 plus b by s plus 1 the whole squared plus c by s minus 4. Now take the LCM in your right side, then we get a into s plus 1 s minus 4 plus b into s minus 4 plus c into s plus 1 the whole squared divide s plus 1 the whole squared into s minus 4. Now the both side, the denominator should be cancelled. Then the numerator which is a into s plus 1 s minus 4 plus b into s minus 4 plus c into s plus 1 the whole squared equal to s squared minus s. Now we have to solve these equations, then we get the values of a, b, c. For that we have to put some value for s. If we take s equal to minus 1, then we get b equal to minus 2 by 5. At the same time put s equal to 4, then we get c equal to 12 by 25. Finally, if you want to put any values for s, then we get a. Otherwise we can using the equating process. Equating the coefficient of s squared, we get a plus c equal to 1. That is a equal to 1 minus c. We know the values of c. What is 12 by 25? Then solve 1 minus 12 by 25. We get 13 by 25. Finally, the answer is s squared minus s by s plus 1 the whole squared s minus 4 equal to 25 by 25 into s plus 1 minus 2 by s 5 into s plus 1 the whole squared plus 12 by 25 into s minus 4. See, already we know which is in your left side is also called y bar. Then y bar equal to 13 by 25 into s plus 1 minus 2 by 5 into s plus 1 the whole squared plus 12 by 25 s minus 4. We already know that y bar is a Laplace of y of t. We have to put that. Then Laplace is going to your right side as L inverse. So L inverse of 1 by s plus 1 can be written as e power minus t. As well, L inverse of 1 by s plus 1 the whole squared can be written as t into e power minus t. Finally, L inverse of 1 by s minus 4 can be written as e power 4t. So the final answer is y of t equal to 13 by 25 e power minus t minus 2 by 5 t into e power minus t plus 12 by 25 e power 4t. Thank you to all.